Welcome everybody to the May 9th OpenJ9 community call. We're going to kick today's meeting off with a lightning talk from Mark Studley. Let you take over, Mark.
Okay, can everyone see that?
Yep.
Okay, so I don't have any prepared slides today. I'm just going to go through a bit of a demo using OpenLiberty and OpenJ9 to show off some of the shared classes and AOT technology that we've got and how you can understand a bit about how it's operating and what's being stored there. So I've just started a standard OpenLiberty web profile Docker container here, just a standard one. I've set up a Docker shared volume here so that I can get OpenJ9 into that container and use OpenJ9 to run OpenLiberty. I started off by just setting up some configuration stuff so that I can access OpenJ9 very easily and verified with a Java Dash version that I am using Eclipse OpenJ9 as the JVM. Sitting in this directory here is where the OpenLiberty server can be started. There's a nice little script called server. So what I'm going to do is just start that to show you that it can work. Now let's time it. Oops, let's time it. Not tie it. Of course. I have to stop it first. Sorry. Demo jitters. There we go. So let's just start it here. And in a few seconds, okay, so that is the default server start time for the Liberty web server profile running in this Docker container on my MacBook, et cetera, et cetera. Mileage may vary if you run it on a different system. So this is not using shared classes. This is just the default startup JIT heuristics that OpenJ9 is using. But that's not the best that you can do. So the first thing that we can do, let me just, I have to do another preparation that I didn't do. It's actually supposed to come later in the talk. But anyway, okay. So I was going to verify that this does not use any cache. Okay, so we can see this list all caches is a subcommand that you can use from Java, which will list any shared class caches that are available on a system. Because I just destroyed that one, it's no longer there. Let me just do a quick proof that I wasn't using that cache before. Hopefully we'll get a number that's around the same ballpark quickly. All right, so 6.9 seconds is about what I'm seeing on my system to start up. So what if we wanted to make this faster using our shared classes technology? So the way that we would do that is stop the one that's there, and then there we go. There's a way of passing in JVM args to the server script, and we can just say share classes, and that will run with the shared classes technology. Now this is going to be a first run. And we actually do a bunch of more aggressive things during the first run in order to prepare to make startup faster. But of course, that has the end result that startup got a lot slower. So here we're at 8.4 seconds compared to 6.9 seconds. So yeah, good job. But if we stop this server and run it one more time, again, using the shared classes option to make sure that it's going to connect to that same cache that it just created, we should see the demo gods have been prayed to appropriately. Okay, so we're down to 5.1 seconds, which is a pretty good improvement already, even on 6.9 seconds. So let's go see this cache that we created. So list all caches is now showing that there's a cache here called shared CC root. You can actually name your cache if you want to give it its own name. You can have multiple caches on the system and then use the name option to connect to them. But I'm just going to use the default one, which just uses a default name and connects the username that's being used to access it. And we can find out a little bit about what's in that cache by using the printstats command. So this is a very simple command, just shows a summary of all the contents that's inside the cache. Some of it is easy to ignore, like the nice little pointers that get stuck in here. But it starts, these stanzas here get a little bit interesting. So we have a cache size of 16 megabytes. That's the default shared cache size on Linux. And this is an interesting line here, free bytes equals 0. That means that there's no space left in this cache. So I'm going to come back to that in a sec. But there's a couple of other things I just wanted to point out while we're looking at stats. So classes, affectionately known as ROM classes here, there's about almost 11 megabytes of classes being stored in the cache, and a little bit more than 3 megabytes of AOT, compiled methods. Now, what is this AOT compiled methods? In OpenJ9, the JIT compiler can actually decide to store the compiled code that it generates as a relocatable code body into the shared class cache that can be reused on a subsequent JVM execution. And what that means is that you can avoid having to do all the effort and spend the time and CPU resources and memory resources to do compilations to compile native code, and instead you can just load that code out of the cache, and that is a lot more efficient, on the order of 10 to 100x more efficient to just load that code from the cache than it is to perform a compilation inside the JVM. And so that's why you can get a big startup improvement, from that. Plus, all of these classes that are being stored here are stored in an internal format that's closer to what the JVM needs when it's loading classes. So when you have a class loading intensive application like an app server that's starting up, you can save quite a lot of time just by having these classes in the cache, and also the AOT code being stored in the cache as well. There's some other stats down here at the bottom just to give you the numbers. So it's not just, this is bytes of memory. This is the number of classes and the number of methods. But I pointed out that the free bytes is 0, so that means the cache is full. So immediately that makes me think, if it's full, maybe there were other things that I could have stored in this cache if it was a little bit bigger. So let's get rid of this cache. You can do destroy. So now we can verify that, oops, that's not what I wanted to do. Trying to go too fast. It just created a new one. Okay, let's destroy it again. Okay, slow down. There we go. Okay, so we no longer have any shared classes on the system, shared caches on the system. Let's do server stop just to make sure we're stopped. Okay, now the default cache size was 16 megabytes. So why don't we try doubling that, which I actually know is a reasonable size to use. So that's the -XCMX32M is the option that sets the maximum size of the shared class cache size. And so that's going to start our guy, and he's going to be slow again, remember, because this is the first run. Right? And then we stop and restart again. Now, technically, I don't actually need to set the size this time because the cache has already been created, but I'll just leave it there to save time. And now we're down below 5 seconds. When I did the demo earlier, that was actually a bigger improvement. But let's go see what's inside this cache now. There's my print stats. There's my print stats. So you can see this is now a 32 megabyte cache, and I've got 11 megs free. So I actually got quite a lot more space in the cache, but I'm no longer free. So I've used as much as I need for the startup of this particular application server. That meant I was able to store 13 megabytes of ROM classes and another megabyte or so of AOT code. So that's even more code and even more classes that I can use to accelerate startup, which is why I was expecting a little bit more of an improvement, but maybe it's just the Docker container is not a great performance measuring device. There's a bunch of other stuff that's stored in here too. There actually is a more detailed option that can use print all stats. This is going to print a whole whack of stuff. But this will show every class that's in the cache. So if there's a class that you really care about, you want to find out if it's in the cache, you can obviously go looking through this output. Sometimes they're easier to find than others. Here, I'm going to go looking for an AOT. Oops, wrong way. Right. So if you see an entry like this, this is an AOT compiled method body for get imported sources in here in this ROM class. So you can find AOT bodies that have been compiled for methods in here, and there's going to be a bunch of those listed through here. Other things that get stored into the shared class cache are JIT hints. So these are hints to the JIT compiler to say what op level does this method need to be compiled at, or does it need to be recompiled to later. So that can save on compile effort in those subsequent runs and make ramp up even faster. And another thing that gets stored into the shared class cache is JIT profile data. So one of the things that we do during that first run is take the profile data that the interpreter has collected about the execution of this method and persists it into the shared class cache, so that in a subsequent run, if we need to recompile that method, we can use the profile data that was collected during the first run in order to make sure that we really generate a very good version of that compiled method. Let's see. So that's basically the summary that I was going to go through today. There are even more options that you can use to track what AOT methods are being compiled. The options that I showed in my earlier talk using -x-JIT verbose actually include entries for AOT loads and for AOT compiles that look like AOT cold or AOT warm. And so those entries can be identified in a JIT verbose log as well. And hope you enjoyed it. It's the end of my lightning talk.
Thanks, Mark. Are there any questions from anybody on the call?
I have a question. So presumably there's a trade-off between how big to set the cache size and something. Why wouldn't I just set it to some huge amount so that everything just always went in the cache and I didn't need to worry about it?
You couldn't do that. I mean, it's going to allocate a bunch of virtual address space. There's also a soft MX value that I didn't specify, which is how we try to control how much space the cache actually ends up consuming. So there's a whole another set of tunings that you can do around shared cache size that can help you use the least amount of physical memory for the environment that you use. But usually we end up tuning it so that we're just using as much memory as we need for the application that's being run.
So the recommendation generally is do a few runs of presumably your production system with these various things turned on and get a good feel for what's going on and set some tuning values accordingly.
And then round up a bit, yeah. Give yourself some space. Yeah. One important thing to know about the shared class cache is that it's not technically a cache in the sense that most people think of caches, in that the things that are stored in the cache can't be ejected. But it is a cache in the sense that it's retaining information that gets used by the JVM and to accelerate things. So,
thank you.
All right. Thanks, Mark.
Yep, got it down to 10 minutes. Almost there.
There's lots of information to pack into that. So, in terms of the rest of our agenda, next week we have a lightning talk coming up with on Metronome GC from Alex. See, Boris is not on the call, so I guess we'll have to wait for next week to hear how the workshop went yesterday. Are there other things in this particular area that anybody wants to bring up? All right, moving on to our general business. Looks like someone has, hopefully Irina, no, she's not on the call today, has updated the summary of the issues list. So looks like overall we're up by one issue and a small increase in the number of pull requests, but a small decrease in test failures, so that's good. So we seem to be holding mostly steady. Is there anything in particular anybody wants to talk about here? I still owe a second pass over the JDK9 issues to see what can be closed out and what can be retagged to 10 in later releases. So, all right. Moving on to machines then. I don't know if it was reported last week, but we received 4 X Linux machines from IBM for our pull request builds. So now we have X Linux and Windows machines in addition to the machines we had before. So starting to flesh out our platform coverage at OpenJ9, which leaves us with the Travis CI builds that we could either disable or repurpose as a CMake testing ground while the CMake work is in progress. My preference is to use them for CMake, but does anybody else have any other ideas of what we should be doing there?
Sounds good to me.
In terms of the UNB work, I know that we're continuing to contact UNB and continuing to work with them towards getting machines, but there's no definitive timeline there yet. So, is there anything else in relation to machines that we should be discussing at this point? So I've pulled out a couple of the issues around builds and platforms and collected them here, so we have sort of one common place to look at. We have the issue for JRE packages at adopt. My understanding is this is a little bit on the back burner, so if we want progress here, we're going to have to pick it up and push on this to make sure that we're getting JRE packages for at least 8. The other releases may be less important or less necessary due to JLink being present. Anybody on the call have any other comments on the JRE packages?
Is there a lot of work to be done to make that happen? Is it just adding additional builds, I guess? Is that? So
my understanding is the JRE image was built already because the builds were running.
Oh, I see.
So it may just be a matter of
capturing the artifact.
Capturing the right artifacts, yeah.
Okay.
In terms of the large heap or non-compressed refs packages, we've done a bunch of the work already at OpenJ9, so it's possible to build these now. Thanks to Teresa, who's done the lifting on that. The next step is to get them included in the pull request builds and the nightly builds, likely for X Linux to start. We can expand to other platforms as required or requested. So I've talked with Adam, and he's going to look at getting those enabled in the pull request builds, likely with a dash large heap for the platform. So the Jenkins command would be something like Jenkins test sanity X Linux dash large platform, and then JDK 8 or 9 or 10 or whatever it may be. And then we've had a request for Win32 binaries. The Eclipse IDE is interested in using OpenJ9 binaries, but their list of supported platforms includes Win32. So, Peter, I think you opened an issue for Win32 builds. If you could paste a link into this, that would be helpful. Cheng, I know, has started looking at getting OpenJ9 building on Win32, figuring out what we need to do in terms of environment changes. So hopefully we will see some pull requests opening up for that in the near future. For Mac OS, I don't have much of an update there. It continues to be on my plate, but slightly back burnered. I need to clean up what I have in my branch right now and push that so other people can pick that up and run with it if they're interested or able.
Do you have any guess for how far along in that process you are, Dan?
It's hard to tell. It's one of those whack-a-mole processes.
Yeah.
Current one is updating some of the M4 code to prepend underscore in front of an EC call. So it's an extra set of macros, and it's just been
Okay.
So hopefully I'll get something pushed in the near future and be able to build on top of that. Are there any other builds or platform issues people want to bring up? All right. In terms of end user experience, I haven't had a chance to check the query here. Are there any of the end user items that anybody wants to call out?
We've been getting some nice social tweets, but I'm not sure if there's any negative stuff that's been showing up on the project. Well, or positive.
Yeah, I'm not aware of any negative things. I'm aware of people finding some issues here and there, but
yeah.
Affected, so.
Yeah.
All right, moving on to the 0.9 release. I've got a link to the support proposal. Thank you, Mark, for having written that up. It was approved recently. So
yep.
Big plus. I believe Sue is in progress in getting it pasted or put up on the actual website.
Yeah, and thanks to everyone for filling in all the information that I didn't take the time to collect when we did the the original version of it. So it's good.
Okay. So the Eclipse release plan has been updated, which is a big plus. Thank you to Peter for running through that process. This was about as far as I got before the call and cleaning up our minutes to get them in a little more of a readable state. So if anybody has items they want to call out in this area, please do so, or items they want to discuss. And we continue to advertise the call on Twitter. And Shelley still has a to-do to paste or to put up some of her blogs around testing. She's got some of them ready to go, I think. And now that we have the new OpenJ9 blog, we should be able to put those up there. So. Is there any other items that people want to discuss? All right, then thank you, Mark, for the lightning talk today, and thank you, everybody, for attending. We'll meet again next week.
Okay, thank you.